everyone. In this lesson, we're going to be solving quadratic equations by taking the square root. If you're in Ms. Drake's class, we are on lesson 67, and that's on page 6. So what we're going to be looking at is examples of quadratic equations where you have a binomial to the second power on one side. So if you take a look at number 2, what your initial instinct might be is to multiply the left-hand side, and then factor, set equal to 0, and solve that way. But we're going to show you another method that you can do today by taking the square root of each side. So the first thing we're going to look at is something called the square root principle, which says if x squared is equal to k, so just pretend that's a number, then x is equal to both plus and minus the square root of k. So let's look at what that looks like in terms of numbers. So if we have x squared equals 4, to solve for x, what we would do is we would take the square root of both sides, like this is saying here, take the square root. So we're going to take the square root of both sides because a square and a square root undo each other. They're on inverse operations, just like addition, subtraction are inverse operations, or multiplication, division are inverse operations. So because they're inverse operations, the square and the square root cancel, which means I'm left with just an x on the left-hand side. Now on the right-hand side, if you take the square root of 4 on your calculators, you're used to getting the number 2. But when we put the square root of 4 in our calculators, they only give us the positive square root. Really, the answer is positive and negative 2. So we write that as a plus over a minus sign in front of the number 2, and what that means is that x is equal to both positive 2 and x is equal to negative 2. So what this symbol means is we put it together as positive and negative at the same time, so it's a little bit less writing for us. Let's look at what that means in terms of the equation itself. We're saying that if you take a number squared, it should be equal to 4. So 2 works because positive 2 squared is equal to 4. Right? If you put this into your calculator, 4 is equal to 4. This also works for the number negative 2, because when you square a negative number, negative 2 times negative 2 is also 4. So both 2 and negative 2 work. Okay, let's take a look at number 2. Instead of having just an x squared on the left-hand side, we have a binomial like I had set up here. We're going to have a binomial squared and then equals a number. So instead of having to multiply this out, what we can do is we can undo that square with a square root. So we can take the square root of both sides of the equation, because whatever you do to one side, you have to do to the other. Since this square is over the entire set of parentheses, the 2 and the square root are just going to undo each other, and I'm left with whatever's in the parentheses. So in this case, it's x plus 2 is equal to, and then you can do the square root of 9 on your calculator, on Desmos or whatever calculator you're using, and you should get 3. But we know from the square root principle that it's not just positive 3, it's positive and negative 3. So up here we just had a positive negative number, so those were our 2 answers. Here we have an expression is equal to positive and negative. So what we have to do is take that positive and negative 3, and we're going to split it up into 2 separate equations. I'm going to set this up as x plus 2 equals 3. And I'm also going to set up an equation that says x plus 2 equals negative 3. Okay, so now I have to solve each of these one-step equations to get my 2 different values for x. So for this one-step equation, I would minus 2 from both sides, and I get x equals, and then 3 minus 2 is 1. So x equals 1 is one of my 2 solutions. And now I have to solve this one to get the other solution. So to get x by itself, I'll do minus 2 and minus 2 on both sides. So x equals, and then negative 3 minus 2 is equal to negative 5. So I have 2 solutions, or 2 numbers that make the original equation true. X is 1, and x is also negative 5. Again, if you plug that into the original, 1 plus 2 is 3, and 3 squared is equal to 9. If you did negative 5 plus 2 is also 3, and when you square 3, you get 9. So let's take a look at number 3. Number 1, the 2 numbers on the right-hand side were both perfect squares. So what we're going to look at for number 3 is when the number on the right-hand side is not a perfect square. Okay, if you kind of look ahead to your answer choices, what happens is when we take the square root, we don't get a whole number, we end up getting a number inside a square root or radical sign, and we just leave that in our answer. But let's go through the steps to see which answer choice we need to choose. So same thing, we have a binomial squared on the left-hand side and is equal to a number. So I'm still going to undo that square by taking the square root of both sides. The square and the square root undo each other because they're inverse operations. So I copy down whatever's in the parentheses, which is x plus 3. You don't need the parentheses, I just rewrote them. And then equals, now the square root of 7, if you put that into your calculator, you're going to get a long, icky decimal because it's an irrational number. So we don't write down that whole decimal, we just leave it in what we call radical form. So we're going to write positive and negative square root of 7 because we know the square root when we take it is really the positive and the negative when we're solving. So now I'm still going to set this up as my two separate equations just like I did for number 2. So I have x plus 3 equals the positive square root of 7. And then I'm also going to solve x plus 3 equals the negative square root of 7. Okay, so now I'm going to solve each of these for x. So for this one, I'm going to do minus 3 on both sides, and I have x equals, now the square root of 7 minus 3, if you type it into your calculator, again, you're going to get a long, icky looking decimal. So instead of writing the decimal, we're just going to leave it as an expression. You can write it as the square root of 7 minus 3, but typically you'll see the number come first. So instead of the square root of 7 minus 3, they would rearrange it where the negative 3 came first, and then you add the square root of 7. Okay. So now this one, we're going to do the same operation to both sides. We're going to subtract 3 from both sides, but now we're subtracting from a negative square root of 7. So x equals, again, we're not really going to subtract them. We're just going to leave it in radical form. So you can write negative square root of 7 minus 3, or if you want to go straight to the answer, the minus 3 would come first, and then the minus square root of 7. So here are our two answers. They look a little different than the whole numbers that we've had before, but let's take a look at our answer choices. None of them are actually written as two separate answers. Okay, the way your answer choices are written is they take that first number, negative 3, see how they're the same for both? And then one of the expressions has a plus and one has a minus. So instead of writing it as two separate expressions, they're going to group it together as negative 3 and then plus and minus. So we put that together, plus and minus the square root of 7. Okay, so take a look at your answer choices to see which one that matches. And it is answer choice 3. Okay, when you turn the page, you'll have 3 examples to try on your own. So pause the video and try those answers. I'll put the answers up in a second, and then you'll try the homework questions. Okay, so hopefully you tried 1, 2, and 3 on the back. Here is the work along with the answers. And if you have any questions, just send us an email.